Today we're going to have a look at tables and graphs. In the first chunk we're going to have a look at the different types of tables and graphs that we've already looked at. In the second chunk we're going to have a look at misleading graphs, etc. But in chunk one, first we're just going to have a look at these different types of graphs. Now we have looked at a histogram. Histograms are used for numbers, and what we have is we have down the bottom we have our numbers. Now we can use, these are what's called class centres. These numbers will go from 0 to 10, then there'll be 10 to 20, 20 to 30, and the class centre is listed in the middle. Now I would note that this is not drawn the way that we would normally, draw it. Normally we're told to leave a half column on this side. And that's so that when we do a frequency histogram, frequency polygon, it looks like which goes to the middle, it's even. So this is a histogram, but it's not drawn correctly. It should have had a half column left to the left between the vertical axis and the first column. Now, a column graph is used for categorical data, okay? Which means data like favourite colours, eye colour, etc., etc. Now you can see the differences. With a column graph, there is a gap between all of the columns because there's nothing linking them together. There's nothing linking red and green. Whereas numbers are drawn next to each other because the data is continuous. We do have links between numbers. They follow on one after the other. Now on both of these axes here is the frequency. Now the frequency is how many occurrences we have. So in this case, if we were doing this could be an exam, and this might be how many people across here scored between 20 and 30 in their exam. So that's the histogram, a column graph. This is the number of, say, people that thought that blue was their favourite colour, etc. Now a dot plot is another way of showing data. It's like a histogram. Now dot plots we can use when we haven't got too many data points and it's easy to count them. So it's the same sort of thing where this is our frequency, but what we do, or how many we've got, what we do is we do a dot for each one. So we can see here that this is equal to 4, 3, 1, and this one here has got data down the bottom. It's sort of almost categorical as well, although it can be a class centre. You wouldn't use a dot plot if you had a frequency of say 15 in there. You wouldn't want to have to count them all up. So dot plots are very similar to histograms. We use them when we don't have too many data points, and it's easy, really easy visually to see how many there are. Under that case, let's say we don't actually have, so let me get rid of that. We don't actually have a frequency thing on the left-hand side because we can count the dots, gives us our frequency. But the number of, we need to make sure we line up our dots in nice rows, in nice, so they're all level, so it's easy to see how many there are. A pie chart, so a pie chart just visually shows us what percentage of each of these things are. So we've got red, blue and yellow here. Now there's 360 degrees in one rotation, and we work out how wide, how big one of our pies are. They're in proportion, so it's very much like our sector. If we had, for instance, let's just say we had 36 items and 18 of them are yellow, or 50%, then what we would do is we would work out how big that angle is there by doing the fraction 18 on 36, and then we'd multiply it by 360 degrees. That would give us our angle for that pie chart. Okay, so that's just a very brief review of that. I hope you haven't taken too long. Then we're going to have a look at, in detail, more interpreting a histogram in our first chunk. Now your exercises, you're going to interpret a histogram and a pie chart, etc. But okay, so if here is our results of a spelling test, remember we've got that frequency, how many people got each result is over here. And then we've got the actual test results. In this case, we've got the numbers one column for each number out of 10. So how many results are shown in this histogram? We add them up. So if I go number of results, if I'm looking over here, one person got 4 and one person got 5, 2 people got 7, 3 got 8 and 4 got 9 and 4 got 10. So there were 15 people did this test, 15 people in the class. So that's A, which is here in our example. Now B, list the results in ascending order. I've sort of already done that. All I've got to do is write them out again. Now, sorry, that's not correct. I have not done that. I've listed how many there are. Now I need to put the results out. So I've got 4, one person got 4, one person got 5, none got 6, 2 got 7, 3 got 8, 4 got 9, and 4 got 10. I'm sorry for being so messy today. Calculate the mean. So now what I need to do is I need to add all those up. Now you'll need a calculator to do that, but I'm going to try and do it in my head because I haven't got one with me, which is probably not going to work. 9, 16, 23, 31, 39, 47, 47, 56, 65, 74, 84, 84 and 40 is 124. So it should be 124, which is the sum of them all, divided by how many there are, and there are 15. So I'm not sure we've added up that right. 9, 16, 23, 31, 39, 47, 56, 65, 74, 84. All right, 124 divided by 15. I should put that in my calculator. 8 and 4/15 is what I'm going to get. So you put that in your calculator and get a real answer. Calculate the median. The median, I've got 15 numbers, so it's going to be this 8th one. That's going to give me 7 on both sides. Remember, you can find it by going n plus 1 divided by 2. We've got 15 results, so that would be 15 plus 1 is 16 divided by 2 is the 8th one. 1, 2, 3, 4, 5, 6, 7, 8. So my median is equal to 9. What is the range? The range is the biggest minus the smallest. My biggest is 10. My smallest is 4. So my range is 6. F, is the data skewed or symmetrical? So looking at it, just looking at my form, really I can see that I've got more just on numbers over here without, at this stage, plobbing it any further. So it's not symmetric. Symmetric would be something that looks like that, right? Sorry, I haven't drawn that very well either. So it's skewed. It's not symmetric, means it's skewed. What proportion of results is greater than or equal to 7? So there's 15 on total, so I'm going to put that in the bottom of my fraction. How many bigger than 7? So quickly I can see there's only 2 less than 7, the 4 and the 5. So rather than count them up, I'm going to subtract 2 from 13. So the answer is 13 on 15. If I quickly look at my answers, it looks like I couldn't add up. If that's right, I couldn't add up my numbers properly. It was meant to be 123. And other than that, it looks like I may have got the answers correct. All right, so our first chunk is going to be on the next page. I'm going to apologise for taking so long today to get through that. So our first chunk, really, if I'm reading these through, this first one is, so you very much like the histogram we just did. A, how many results? So add them up. B, then, as I did in the first example, list the results in ascending order. C, calculate the mean, like I did in the last one. D, calculate the median, find the one in the middle. E, what is the range? F, is the data skewed or symmetrical? And G, what proportion is bigger or greater than or equal to 8? They are all exactly the same, this question, as the example I just done. Now the next one down here is showing us a dot plot. And there are, it looks like it's going to ask us pretty much the same thing. A, how many? So now you're just counting dots. B is asking you the mode. So you're looking for the tallest stack because our mode is the one with the most on it. So here you just look for the tallest stack and then find out what that number it is. Sorry, B is range. I'm apologising. Range is the biggest minus the smallest. C is the mode, which is the biggest stack. D is what is the median height. So you're going to have to list them or you have to find the median. You could also, once you know how many there are, you could use that formula, which means that the number is n plus 1 on 2. That'll give you the position, and then you can actually count up and see what dot's in that position. Mean height. So median was D, mean is E. You're going to add them all up together, add up every single one, and then divide by how many there are. And then F, what value is the outlier? Which one is a long way away from the rest? And you write that in an F. Our pie chart now shows proportions of deaths in Australia from diseases caused by smoking. We've got the green one at lung cancer, the blue one at other cancers. This light blue one is disease in blood vessels. This one, 5, is the cancer of digestive organs. This one is breathing. And this one is various medical diseases. Now, it tells us about 15,000 Australians die from smoking-related illnesses per year. Now, the first question, A, is asking us for the total percentages caused by cancer. So the way we're going to do this is we're going to have for the percentage, you've just got to read off the number caused by cancer. So you're looking to add all of the cancer ones. So you're adding these 3 colours together to give you a total percentage for cancer. B, how many smokers die of smoking-related cancer in a year? So first you had the percentage. Once you've got the percentage, you're going to get your percentage, remember. So if it was 50%, remember, the percent is divided by. So you're going to go 50 divided by 100. Then multiply it by the total number. And the total number is 15,000. So that 50% was just an example. You're going to use whatever answer you got in A to divide by 100 and multiply by 15,000. How many smokers die of smoking-related cancer each day? So there are 365 days in a year. So you're going to divide your answer in B by 365, and you're going to round it to a whole number. So whichever is the closest whole number. And it asks us for how many smokers died from various breathing diseases each day. So various breathing diseases, breathing diseases is this one. This red one is breathing diseases. So you are going to do the same thing as first. You've got that percentage. You're going to divide that percentage by 100, multiply by 15,000, which is the number of Australians dying. And then you're going to calculate the sector angle for lung cancer. So lung cancer, you're looking for the green one. You've got your percentage. You are going to multiply that percentage by 360. So you're going to have your percentage, and then you're going to, so remember you have that, the percentage means divided by 100. So you have your number, if it was, and then you're going to multiply that by 360 degrees, and that is going to give you the sector angle.